Hello everyone and welcome to the AutoLife. Last year I was lucky enough to travel to the UK, and one of the places that I went to was a place called Cosworth, a name synonymous with performance and racing engines all around the world. I actually thought it would be a 10 or 15 minute interview, but it turned out to be something much more. Part one will be Chris Willoughby, the commercial director, taking us through the history of Cosworth and what a history it is. And then he takes us through most of the engines that they've built, of course, for racing cars all around the world, but indeed road cars. In part two, we open up this Cosworth box for much more information, where we go through how components for Cosworth engines are made, designed, manufactured, tested and run to build the most amazing competition engines, theoretically, in the world. Ladies and gentlemen, welcome to the AutoLife and welcome to Cosworth. This is going to rock. Ladies and gentlemen, may I introduce Chris?
Good morning.
Chris, everyone. And can I introduce Lisa as well? Lisa is from Influence Associates, based in London, and she organised all of this for us. So we are very lucky to be in here. Chris, talk us through some of your beautiful engines that you have in here.
Well, I'd say the start of Cosworth in 1958 is the era that I find most interesting. And I think if you think back to that era, it's sort of post-war years, there were people like Colin Chapman, and sort of Cosworth in some regards was a spin-off from Lotus. In fact, Mike was still working at Lotus when Keith actually formed the company. And out of a very small sort of group of people spun what is now the UK motorsport industry. You know, there was Colin Chapman, even people like, I think Graham Hill was like working for Colin Chapman in the stores sort of thing. So there was just this really small group of people that went on to great things. And I think, I was lucky enough to meet Mike and Keith.
So could I just ask you, Cosworth, tell me about the names Cos and Worth.
Mike Costin.
Yep.
So he was one of the founding partners, and Keith Duckworth. So the Cos is Costin, and the Worth is Duckworth. And they met at Lotus, I believe, and so they obviously formed a relationship. I think knowing their characters, they were always going to have to go off and do their own thing. You know,
Right.
Particularly Keith. You know, he was a very had strong opinions, super intelligent, both of them, and I think it was probably destined they were going to want to go and do their own thing. And they started in sort of fairly in a fairly small way, making Formula Junior engines or tuning Formula Junior engines, and I think all they wanted to do to start with was just have fun in motorsport. Yeah, I think the original plan actually with Cosworth is they originally wanted to develop a chassis and be a chassis manufacturer, but they did
really?
the engine thing to kind of keep them busy, and that turned into the company we have today.
And did Colin Chapman approach Ford for the funding, and Ford then approached?
I think he was involved.
Cosworth?
I don't know the detail
Right.
of those of that discussion, but it does now seem a sort of improbable jump to go from making, this is an F3 engine, and to go from making engines that were based on the sort of Ford Anglia cylinder block. We made our own cylinder heads and lots of the engine, but to go from that, which is it's not a straightforward engine, but it's nothing like a Formula One engine. To go from that to the DFV. And I think they must have won the contract just purely on their strength of character, and their intellect was obvious when you talk to them, and so they managed to convince Ford to fund this engine project, and obviously it went on to win first time out, and was dominant in motorsport. You know, it was the right engine for the right time. It enabled a lot of the teams that we have today to go racing. You know, you could go and buy a Cosworth engine and a Hewland gearbox and make your own chassis, and you could be on the grid of a Formula One race.
And of course, it's still in the rear of a lot of, or hundreds of historic cars.
Yeah, absolutely.
All around the world. So do you have an historic section here that looks after those?
We don't have a dedicated historic section. We can make most things for most engines still. I mean, there is an industry that supports these engines still.
Yes.
We used to make some parts for them. We don't anymore. But I think it's something, you know, our heritage is really important to us. And I think, you know, as interest in those historic cars and engines grows, I think there's actually a growing case for us to support that market a bit better. So the DFV and really to make an engine, well, I think that one of the amazing things is sort of Keith just went home with a drawing board and a calculator and designed the engine. You know, it was almost a single-handed effort. And there's quite a lot of new features on the engine. You know, the gear-driven cams, you know, which famously were a bit unreliable to start with. But you know, all of that now. You know, when we do an engine today, we don't have a massive team of people, but we have a lot of analysis tools. We've got a lot of background data, and Keith had none of that. So that, you know, it's almost mind blowing that is the product of such a limited group of people.
It's amazing. This was the DFV Cosworth engine, which was the pioneering engine for F1. Amazing. Wow. Thank you for showing us.
And that sort of set the blueprint for the way we do things at Cosworth in lots of ways. So we were founded in 1958. We moved to the site in Northampton in 1964, and we did that engine 1966, and it won its first race in 67. And really, sort of, so for us, it's not just designing the engine; it's manufacturing the critical parts as well. Which we did for the DFV and we still do today. So more so than any other engine, that sort of set the DNA of the business. And there were lots of offshoots from the DFV. You know, we went to the US and went champ car racing. And it was a good business. You know, a significant number of teams used our engines. They needed rebuilding relatively frequently, so there was a good business in rebuilding the engines, and that spun off a lot of other businesses that still exist today in terms of companies that were actually founded by rebuilding the DFV or making parts for the DFV.
Can I just ask that the maximum RPM of the original DFV was about what?
I'd have to go and look it up, but it was probably around about 12,500, something like that.
And I would suggest in those days that would be a very high revving engine for that period of time.
Yeah, it was. I mean, what's interesting when you look back at the DFV now, I mean, if you look at the Gordon Murray T50 engine, that runs to just over 12,000 RPM. And yeah, the capacities don't, you know, the Gordon Murray engine is a 3.9 litre, so a little bit bigger than the DFV. But in the GMA engine, you've got a durable, emissions capable engine that delivers more performance than a Formula One engine back in the day.
Yeah, and that's in a road car.
Yeah, in a road car, and it meets all the emissions legislation. So it shows how far things have moved, and to look at them, I mean, there's lots of things that still are identifiable. You know, the 4-valve layout of the combustion chamber and things like that. But things have moved on a lot for a lot of different reasons. You know, materials technology has moved on, analysis techniques have moved on. Just the size of the engineering team has got a lot bigger.
the use of the materials inside have changed a lot, or not so much?
I think
There's probably some secret things in there now.
I don't think we had titanium in the DFE, whereas we'll use titanium now. But a lot of it is around things like so the cleanliness of materials, the material data, so you can design more accurately to it.
Yes.
Things like that, and knowing how to process materials to get the best out of them. So there's a lot of knowledge there. A lot of that comes off out of the aerospace industry, of course. But probably the single biggest thing is the analysis. Back when Keith did the DFE, it was a slide rule and a drawing board and hand calculations and things like that. And now we
put it on the dyno and have a crack.
Yeah, and actually today it takes us longer to get an engine to the dyno today than it used to maybe 20 years ago. But when an engine goes on the dyno now, it runs first time. We have very few problems. You always have a few minor niggles, but the main bits work. We know exactly what the piston's going to do, and the crank and the conrods and the bearings and all those sorts of things. Whereas back in the 60s, 70s, 80s, 90s, a lot of that was a voyage of discovery, and it was an evolution of last year's engine, or you'd do some specific calculations around a certain bit of the engine. But now it's such a comprehensive sort of analysis approach to the engine. Everything's pushed to the ragged edge, and that's how we can push engine speeds up. We can get the high performance with the emissions, because it's not, people tend to focus on the hardware analysis, but we do a lot of combustion analysis. So we understand how the air enters the engine, the motion of the air within the cylinder, how the fuel mixes with the air. When you initiate combustion with the spark plug, how that propagates through the cylinder. So we understand way more today than we ever did back then. But I think it's sometimes you look back at how people did those engines, and it just
staggering.
It's mind blowing that they did that.
And Chris, could I ask you, back in the days of F1, we had 18,000 RPM max.
We went to 20 before they put that limit.
20,000. If I haven't been very good at maths, but if I do a little calculation, 18,000 RPMs, does that mean that the piston and rod is going from top dead centre to bottom dead centre 300 times a second?
Yeah, it's going from top dead centre to bottom dead centre and back up again.
So that is amazing forces inside an engine.
Yeah, and I often think if someone came to you today with the idea of an engine, you'd look at it and say that would never work. There's so many things that have to work, so many sliding surfaces that have to be lubricated, so much heat you've got to get out of the pistons. So many things. The timing of the cams relative to the pistons. We run the valves so close to the pistons on race engines. A layer of carbon doesn't build up because there just isn't space for it to build up. So, all of those things. We're obviously very biased here, but I think the engineering and the challenges within an engine, it's very hard to point at other things that have such a variety of engineering challenges. I'm sure people would disagree, but there's so much going on inside an engine.
And Cosworth is all about engineering challenges.
Yeah,
and finding solutions. Yeah.
Yeah, and there's no secret to it. It's a very scientific process. I think there's a bit of creativity in there as well. I think, when people go looking for new solutions, that's definitely a creative part of the process. But yeah, we need a high density of very capable, very motivated people that work well as a team. I think that's another thing that people normally comment on when they come to Cosworth is, the whole organisation works well together. There's not political tension between different departments or anything like that.
Sure.
And I think you do need
Very important.
You need a culture of honesty. You know, if something is not right, or if something we need to change in what we're doing, you know, everyone needs to have a voice. Everyone, you know, the whole organisation needs to work as a team. And I think it's interesting. You know, I talk to people in more mainstream industry, and they talk about agile working practices, you know, with small focused teams and a high cadence of review and things like that. And we've been doing that for decades here. You know, that's the way we work. You know, when it's interesting, when we were doing some of the early combustion chamber work on the road cars, you'd see the teams of engineers huddled around the CAD tube. You know, we wouldn't go off and do 20 slides and, you know, have endless meetings about it. Everyone would get around the CAD tube, and everyone would be commenting about what they can see on the screen.
Yeah.
And you step through iterations quicker. You get all the expertise out on the table very quickly by that approach. So I think that, you know, that's one of our strengths. And there is, you know, it'd be nice to say there was a pot of magic dust somewhere that we could sprinkle on things, but it is just
hard work.
It's hard work and a lot of engineering, a lot of science, and a lot of experience. You know, there's lots of people here that have been here for 30 plus years.
Well, how, if I could ask, how many years have you been here for?
I started in 1990.
Right.
So yeah, 34 years.
34 years. So you started when you were 4.
Yeah,
That's amazing.
Right.
You started
exactly. It's
very
amazing.
young.
Yeah.
Chris, if I could just ask you, we seem to, it's 2025 now, we seem to, for the last 4 or 5 years, we've been in the era of hypercar engines.
Yeah.
Cosworth is the king of hypercar engines. We have the Aston Martin Valkyrie, we have Gordon Murray's vehicles, and of course we have the Bugatti Tourbillon. When Mate Rimac or someone from Aston Martin, whether it be Adrian or whether it be Gordon himself, come in, sit in the boardroom with you and whoever it might be, and say, I need this, and it must do this, and it has to weigh this, and it must reach these revs. What's the thought process that goes into that? Is there ever a stage where Cosworth would say, we can't do this because, or does Cosworth work out a solution and maybe go above and beyond to what their original thought process was, looking at the overall project of the supercar / hypercar that they want to bring to market? Because these are road cars.
Yeah, and that's the additional dimension that makes these engines hard. They've got to be emissions capable. And the thing with emissions is there's no nearly passing. You know, they have to pass or you can't sell the cars.
Yeah.
But I think the earlier we engage with customers, the better. So we'd rather talk to customers when they have a vision of the car. And then what we'll do, we typically do a 3-month feasibility study or concept study on the engine. And we do a lot of performance simulation. We'll sort of design the engine at a high level in CAD. And in that period, we explore the art of the possible. So really the customers that come to us and they say they want 1,000 horsepower and it needs to weigh 180 kilos and rev to this, we want to explore the art of the possible, because it might be possible to get more power or make it lighter or whatever. So that 3-month concept study is really important in terms of conceptually designing the engine. And there's always an element of risk. You know, everything we do, our customers expect us to push the boundaries of what's possible. And so we do a lot of analysis in that first 3 months. But we don't dilute it. You know, we don't do the analysis and then knock 5% off and say, well, you know, let's tell the customer that's the performance. So there has to be a lot of trust between us and our customers. We have to be able to be honest and say, look, this is where we can think we can get to. You know, we'll shoot for that target, but you know, you need to know there's no contingency in this. And I think with it, you know, all of our key customers, I think that confidence, that trust they put in us, and the open way we can work with them is the way we achieve what we can achieve. If someone turned up with a big contract that was going to put us out of business if we missed the performance target by 10 horsepower, that's not the game we're in, you know. And I think particularly, you know, most of our customers understand that because they're doing that with the car, you know, and so it makes a lot of sense. But yeah, so that's how we work, really, very collaboratively, and we're very honest. And if we have, you know, if things aren't going right on the program, we will be open with our customers. And you know, there's a lot going on, and sometimes things do go wrong. Less so now than in the good old days when you'd be picking up pistons out of the drip tray on the dyno, but they still do go wrong. You know?
Yeah, sure. Talk me through some more of these engines.
Right, okay.
These beautiful pieces of art.
So this one here is the GB, so that's when we went to the 1.5 litre turbo in Formula One. We were a bit late to the turbo era, and I think that was, at the time, Keith was very against going towards the turbo formula. Well, I think that theoretically you can, the way the regulations were written, effectively you could run the turbos like a gas turbine and get, in some ways, an unlimited amount of power out of the engine, because the capacity, the 1.5 litre capacity, only refers to the reciprocating, you know, the piston bit of the engine. Whereas if you ran more air through the engine and ran the turbos like a gas turbine and then connected them to the back of the crankshaft, then there's no limit. And so I think Keith campaigned against turbo engines for a long time. It was inevitable that he wasn't going to get anyone to change their mind, so we had to do the turbo engine. So that's the engine here. The next engine along is the BD engine, so that ended up in the sort of Mark 1 RS 1600 onwards, and derivatives of the 4-cylinder engine. You know, I mean, they ended up in turbocharged in the RS 200. So this was used in a lot of different engines.
Applications, yeah.
And
now this one brings back a lot of memories.
Yeah, so it's the Sierra Cosworth, and the one we have here is actually the RS 500 engine.
Right.
So it's got an extra set of injectors, and it's got a larger turbocharger. And the Sierra Cosworth, it was done as a homologation special for touring cars.
It was. It did very well in Australia.
It
did very well in Australia. It destroyed the Aussie V8s.
And so that, probably more so than any other engine, certainly in Europe anyway, the Sierra Cosworth kind of put Cosworth into becoming a sort of household name, more so than anything else that we've done. And I guess it's sort of, we've got year-on-year evolution of race engines. So these two are Champ Car engines. We've got the Zetec V8 here. So this is the engine that was in Schumacher's 94 championship winning
Benetton car, yeah.
Benetton car.
Wow.
And more Formula One engines. This is an interesting sort of evolutionary step. I mean, it's not quite this engine, but you can see what the engines look like in the sort of early, very early 90s. And this engine here was really when we brought analysis techniques in and set out to design the engine as light as possible. So it was quite a brave step. But the interesting thing is, I mean, that weight on the floor, 20-something kilos. That's how much weight we took out from one evolution to the next evolution on the Formula One engine. And you can see almost, you know, at a conceptual, almost philosophical level, the engines are designed differently. And really, when you look at modern Formula One engines, you know, they all have the similar sort of approach. Now, where absolutely everything, you know, a bit like the Colin Chapman sort of philosophy, nothing needs to be there that's along for the ride sort of thing.
This is where you come to work every day.
Yeah, it's pretty cool.
It's beautiful. Thank you so
It's pretty
much
cool.
for.
But that's one of the nice things
showing all
about
of
showing
this.
people around. You know, you sometimes you do become a bit blind to it. So it's nice to show people around that aren't familiar
amazing,
with
this
it, and
is
it does
history.
remind you what's here, what's the history of the place and what we do now. So more Formula One evolution. So we before they put the rev limit on the naturally aspirated engines, we ran to 20,000, which, you know, with naturally aspirated engines, engines are in lots of ways, they're just an air pump. So the faster you can run the engine, the more power you get from the engine. So, and it's a constant technical battle. You know, once you get the engine reliable, you'll push the speed up until the next thing breaks, and then you've got to solve that problem, and then you push the speed up again. And so to get to 20,000, we think before anyone else. It's sort of hard to tell, but you can tell from measuring exhaust frequencies what speed people are running. So we were measuring exhaust frequencies at that period of time. So we think we got to 20,000.
That is serious forces inside the engine.
Yeah, and you get a whole new raft of problems. The engine becomes torsionally very active, so you have to better simulate the torsional behaviour of the engine. But for us, I mean, I think this is the era where racing changed for us. And we were owned by Ford for a short period of our history, but outside of that, we've been an independent company trying to make a profit from all of these ventures.
Yes.
And I think Formula One's a really good example, where when they extended the life of the engine, you know, when we used to go to races when engine life wasn't mandated, we'd put a fresh engine in every day. If you had a problem with an engine, you might put 2 engines in a day.
Yeah.
So you go to a race for a 2-car team and probably burn through 8 engines in a race weekend. That meant people like Ferrari or Renault or whatever, it was really hard for them to concentrate on anything other than the works team. When they started to introduce one engine per race weekend, all of a sudden that means to supply another team, someone like Renault doesn't have to make many engines per year. So that allowed the OE manufacturers to support more teams on the grid. They've got huge development budgets because it's a marketing cost to them to develop the engine. So it sort of squeezed the independent engine manufacturers out of racing. And, you know, it's the right thing for the sport. So, you know, but we, as a company, we had to change. So we had this sort of skill set that knew a lot about race engines, high-end race engines. We had a lot of capability in terms of making engines. You know, we make all the main engine components within an engine. And so we had to sort of take that skill set and that company and take it to somewhere else that wasn't racing because that market had changed. And I think, the hypercar era, which, you know, we're in now, I mean, it's a perfect fit. It's all of those old skills from the racing era. It's still that same DNA in the business and the approach and many of the same people, but we've had to bolt on this understanding of emissions. And I think, emissions, they're really hard. You know, there's no emissions scalability for a big engine to a small engine. It's absolute. You know, we have to meet the same emissions standards as a Ford Fiesta with our engine.
Yeah, which is
quite rightly.
Yeah,
you know,
yeah, of course.
And so,
however, there's a lot more cylinders.
Yeah, there's going from a 1 litre Ford Fiesta to an 8 litre hypercar engine.
Yeah.
You fundamentally got each cylinder has to be so much cleaner in comparison to a smaller capacity engine. But I think the thing is, you know, we had to understand the engine in detail to go racing. So actually, it's the same sort of knowledge base turned at a different problem slightly. You know, we had a really good understanding of the air motion within the cylinder and things like that. So when when you're doing a different thing with that air and you want the air to do a different thing, we understand sort of how to do it. So, and I think the other thing that makes us unique is the fact we manufacture the main engine components. So we can support our hypercar customers by not just designing, developing an engine, we can deliver a complete engine, line side, fully built, tested, warranted to them.
And most components are made on site?
We make all the main components. So we make
okay.
cylinder head, cylinder blocks, cranks, cams and pistons, and the other large components, so covers or cam covers, that sort of thing. We've got a local supply base, which is sort of motorsport, aerospace type supply base.
Yeah. Well, Chris, can I just ask you a question?
Sure.
In this room, what's your favourite engine and why?
Tricky.
Look at this.
Tricky.
Or are they all? Are they all? There must be one who you give a kiss to every morning when you arrive to work. Do you do that, or is it only me that does that?
I don't think I've kissed an engine.
Oh, you haven't?
No.
Okay.
No.
If you could let me know which one is your favourite, I'd like to go over and give it a little kiss if I could.
I think probably the Sierra Cosworth engine.
Really? Okay. May I ask? Am I allowed to go over and give that engine?
Yeah, you can
a little
kiss them all if
Thank
you want.
So much.
We can't.
I'll give this one
I'll probably
just a
wipe
little
them
kiss.
down a bit.
It's interesting because I lived in Japan for 12 months, and my company car was a Sierra Cosworth.
Nice.
Yeah.
Well, that's it.
I'm just coming over here just to give you a little kiss. I'll give you a kiss here. Beautiful. Well done. Okay, we'll be back with Chris with more in a moment.